Hi, all. I'm audible, right? I don't know how many people are there. Oh, we have five viewers already. Aryan Shah, Abhishek Sharma, and be active, guys. I want more likes than viewers, as you people know. Uh, so today I'll try to solve easier problems. Okay. Hey, viewers are reducing, but I will start if we get like five viewers maybe, or 10 viewers too. Yesterday we got 10 viewers before starting, right? So should I wait some more time or? Yeah, today I will solve easier problems which are 2100 to 2300. These are easier than yesterday's 2600 to 2900, right? Okay, we have 10 viewers already. That's a lot. So today we will solve easier problems than yesterday. If anyone going to be more active, I mean, if anyone going to stay for longer time, they can try to send some messages, I guess. Then I can try to see or maybe interact with them a little bit. Okay, we have Aryan Shah being active. So probably I will just open some 21 to 23 and then I should probably wash my face. Easier. Relative. Relative. Sorry, relative. Compared to them, they are easier, right? I'm not telling this they are easy, okay? Sinod is back too. Uh, okay, Sinod is back too. I know him. I've known him long back. I think so. Yeah. Let me try. So let's all try. Let's all try some. See, yesterday we have tried 26 to 29, right? Even before that day, we have tried 26 to 29, I think. So now we're trying easier problems. We'll just try to solve them. Okay, be ready. And if possible, you guys can try to take a pen and paper to try on yourself too. Okay, because on streams, I cannot do very quickly, probably, right? So I will take some time. So, like the video too. So, uh, yeah. Am I sharing my screen? Yep, I am. And now let's go to problem set. She's got glitter for skin, but ready is in the night. Should I hide solve problems or no? I just keep them. What's wrong in keeping them? Okay. So we won't see rating because if you see rating, we'll get scared, right? We won't see if it is 21 or 22 or 23 because all of them are same anyway, so we won't see them. So let's open some problem. Okay. Lanes, of course, I have read it in contest. I don't like it, so I won't do that. What is token removing though? I don't think I have done this problem. I have read this problem before. I don't think I have read this problem before. So let's try this. Okay, I'll give this problem for you people. See, guys, try to take a pen and paper so that you can write. First step is reading the problem clearly and then trying to make your observations, small observations. That's the first step. We need 10 viewers for me to proceed, but it's fine, I guess. We got 10. I started once. It's fine, I think. So Sainath and Aryan Shah, I think Abhishek Sharma, I think all of you will try to stay, right? So let's try to solve this. Don't attend with your fake accounts, okay? Don't open in incognito or such things. Uh, so let's try to read this problem. Okay. When we're out in the club, laughing loud. Define a sequence of integers A, valid, if and only if for all numbers if ai less than or equals to I. Then we call a sequence of integers valid, it seems. Okay, this seems a bit clear. We define weight of f of a valid sequence A of length n. So we have f of A as weight. Initially, a token is placed at each integer point in the closed segment 1 comma n on the number axis. Initially, a token is placed on each integer point, it seems. So we have 1 to n closed segment on the number line, and then we have a token on each of these things. Now we have to perform n operations in sequence. During the ith operation, if ai not equals to 0, remove a token in a closed segment ai comma I that has not been removed. Otherwise, do nothing. So during ith operation, if ai not equals to 0, remove that. Otherwise, do nothing. So if ai is 0, we won't do anything. If ai not equals to 0, what's the specialty of 0? Okay, let's just listen the operation. See, reading the problem is half the step. So read carefully. F of a is the number of ways to remove tokens. Two ways are considered different if there exists a t such that the positions of the tokens removed by two ways are different at the tth operation. So the sequence also matters. Okay. For example, 0, 2, 1, because we can remove tokens on 2. Here we cannot remove any token, right? Here we cannot remove any token. And then here, okay, AI 0 means you need not remove that. You need not remove anything. If AI is positive, from 1 to, I was thinking of 0 based index, so I was confused. If AI is 0, that means you won't remove anything. If AI is non-zero, you have to remove something from AI to I. Among them, you have to remove something. That's the restriction, right? So we have f of n. Now what are they asking? Gives you two integers n comma m, ask you to find the sum of weights over all n plus 1 factorial sequences of length n. Since the answer may be too large, print it modulo m. Okay, so now we have the question. We have some valid sequence, we have some weight, we have we should calculate sum of weights over all possible valid sequences given n comma m. So given n, we need sum of weights over all possible valid sequences, right? It has multiple things, but if there are multiple things, that gives you scope to try the problem, that gives you scope to uh, try the first step. Because if there are multiple steps, you can try to first work on what is weight of f of a, and then you can try working on how you can sum it over everything. So if there are multiple things, that means the problem is easier. So this is probably an easy problem because you directly have some things to work on, right? You can directly work on what can be f of a. You have to give importance to this, you have to give importance to these two things, and then you will try to find what is f of a for some sequence, and then you have to count that sequence over all possible valid sequences. If you see number of valid sequences, a1 can be 0 or 1, right? Means a1 can be two things, a2 can be three things, a4 can be four things. So total number of things are like n plus 1 factorial valid sequences, right? A1 can be two things, A2 can be three things, up to so on, AN can be n plus 1 things. That's why we want the sum over all possible valid sequences. Let's try to see what is f of a. And then let's try to find how we can find the sum. M is just modulo. So is the question clear till here? Hi people. Yeah, that's what, right? Kailash, that's what, right? So all the questions will try to scare you off. Until you solve the problem, you don't know if it is a difficult one or not. Until you try to do something on the problem. That's why, but then you guys will just see A, B, C, D, E. With the first letter of the problem itself, you guys get scared because it's D, because it's E. See, really, reading, that's why I forced you people to read higher rated problems, because where does he work, guys? Where do you work, bro? What the fuck? I'm just working at Apple. It's not too much. I know from your perspective, from my perspective too. But yeah, I'm not doing too well in there too. I just did. I will even have night meetings. After that, I came to stream. So Kailash, you were right that this problem is like that. Okay. So is the problem clear? I shouldn't be distracted though. Oops. Yeah. Right. Yeah. So now we will try to see how complex this f of n can be, f of a can be, right? We have to see that. So we have valid sequence a if 0 less than or equal to a less than or equals to I. F of a is some token removal process, number of different ways of some token removal process. We need sum of f of a over all possible valid sequences, which are n plus 1 factorial. This n plus 1 factorial should be simple. 2 into 3 into up to so on n plus 1. That's just multiplication rule, right? Uh, we just form this. So what's the first step? Work on f of a. Right. This is the first step. So let's try to see that. Okay. Given array A, can you find f of a? Can be the first step, right? So if you people are trying, try to take a pen and paper and try to think or try to try. Okay. We don't know if it is 21 or 23, but it doesn't matter, right? So if all of them are zero, it's one, but we know that. But let's try to see what's the restriction. When you are at I, if it is zero, you don't remove anything. If it's one, if it's AI, you must remove something from AI to I. One thing we can say is it's always possible because you can remove token at I when at I. So it's always possible, right? Whenever you are at I, from I to AI, you have to remove something, right? You can always choose AI. Let's try to think. There is some restriction probably, not just restriction. Let's try to count. Let's try to count in some good way. Uh, it's always possible. So f of a is probably greater than zero because we can just keep removing token at that place. But now what's the restriction? I to a of I to a of I, right? So when I to a of I, number of things that have been taken will matter now. But is that a fixed number? Is that a fixed number? No, right? So I'm trying to see if this number is fixed. Okay. From AI to I. So let's say we keep coming from that side, and then from AI to I, we have some tokens, right? Maybe some J had, maybe some AJ was here, and then till here, and then we had till here. So for this, if this was removed, then we will have lesser things here when removing I. But for this, if this was removed, we will have more things here when removing I, right? it will very likely will become simplified. Okay, it will very likely become simplified. We just have to hope and see clearly. This is the first basic thing we can check, right? So while at a of I to I, these are the tokens possible, but then some of them might have been already gone. Then you can only take remaining things that you can do in a of I into I times. So it's not being that simple, but let's try to see. Let's try to see. There would be something fixed. We have to keep some time sometimes, okay? Sorry, grinding into abyss, I don't think much about that. So guys, let's keep some time. It won't be difficult, but it won't be instantaneous, right? We have to work on the problem. So let me try to think a bit. We have such segments, and then we want value of number of different ways to take. So you people would prefer in general examples, right? So if you try to see, for one, we are not remove anything. For two, we can remove only from this thing. So it is one way. So we must remove token at two. And then for one, we can remove token from here to here. We can remove this or this. So two ways. So that makes sense. But let's try to make some point, okay? Let's try to make some point, okay? No hero. Da-da-da. Maybe for the last thing, what can we say? We can either remove that or we can remove one token before this, right? What happens at zeros? What can we say at zeros? What can we say at non-zero things? One thing we can say is if initial ones are non-zero, if initial, let's say uh, non-zero, 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 non-zero. Let's say first zero occurred here. Okay. What can we say is for all of these things, if it is non-zero, it must be one, and then we remove one, and then if it is non-zero, it must be uh, less than one. But whatever it is, you must remove this because this is already gone. So you must remove this. So if it is non-zero, if it is 1, 2, or 3, whatever, if it is non-zero, you must remove that. Again, if it is non-zero, you must remove that. So its number of ways is 1 into 1 into 1 till here, and then you are here, and then you have some zeros, let's say, and then again, let's say you have some non-zeros. So till here you're not removing anything. So again, it's like the same pattern of we have some non-zeros, but then you have this lenience. You have this lenience of being able to choose some things from this set, right? But then these things will also have restrictions, like you can only choose from here kind of restrictions. You can only choose till here kind of restrictions. Till here it doesn't matter. It's becoming very restrictive. But then here it depends if this thing goes till here or if this thing just stays here or if this thing goes till here. Based on those things we can Answer varies, so it doesn't seem that simple. But let's try to still see if something gets simplified. Trust me, the problems, the higher rated problems I have solved, all of them have simple solutions. Yesterday I tried a lot, but finally they will have simple solutions. And I remember you, Ahmad Elaman. We once discussed a little bit on uh, some Sunday, and then I've seen your LinkedIn too once. So let's try to see. This thing is simple. Whatever the initial numbers are, until the first zero comes, they don't matter. It is just one, because once you remove this, there are only, it max one thing here, and then it max one thing here, right? So now here you can remove this shit, or you can, for all these things you can definitely remove this, but then if you are here, let's say this thing goes till here, okay, and if this thing only comes till here, let's just try to see what it will get simplified to, because it will get simplified, that's for sure. Otherwise, if we cannot get any points on f of a that lets us find the sum of f of a over all possible a, then we cannot solve the problem. That means either the whole f of a will get simplified, or we will get something which lets us solve the whole sum, but that will be much difficult problem. For 2100 or 2300 or any rating, mostly f of a itself will get simplified. So the f of a will get simplified, so let's try to see how will this f of a will get how will this f of a get simplified. So anything that's still here is useless, right? I mean, if something crosses all of this and goes still here, that's useless, because we know all of these things have been removed already, right? So these things can come till here, or till here, or till here. It's like that now, right? It's like that. So let's see how this can get simplified. Okay, this will surely get simplified, so we have to see and try. Yeah, it's fine, bro. So try sometime. I will also try to think, you guys also try to think sometime. Okay, try to work on these things. We have, let's say, c things here, c zeros we have. If this thing ends till here, and then this thing ends from more than those things, and then everything ends more than those things, and then everything ends more than those things, then it's very well solvable. Because if it is covering till here, and then if it is covering till more than here, that means it can take its length number of different things, and then it can take its length times minus 1 number of different things, and then it can take its length times minus 2 number of things, because two things have been gone. So if this covers till here, and then if the next thing covers more, and then the next thing covers more, then we can calculate. Because if this has gone, so let's say if this was still here 3 into 3 times, and then let's say if this was still before that, then one has been gone among those, then again we can calculate, right? Then again we can calculate into 4 times. So those things also we can calculate. But let's see what happens if this thing comes till here, but then this thing only comes till here. So now we have a problem, because now this can come outside, this can come outside, or it can come inside. If it comes outside, then you can take anything from here. But if it comes inside, then you can only take minus one number of things from here. Right. So that's what the initial thing also we know. From here, we want to know the number of choices we have here is number of tokens that are left here. That many choices we will have. Number of tokens that we have here. That many choices we will have at every step. So that's what we were telling in the beginning too, right? Like if this has been taken, this will be minus one. If this has been taken, this will be the same thing. But then all of this will get simplified. We have to think some more time. Let's just think it will get simplified somehow. Guys, if I'm taking more time, that's good for you people. You guys can try on your own more, okay? Try 26 minutes. Let me try to. I have to talk to keep you people entertained. Try to take a pen and paper and try to work on these things. Try to find something. Some things take time. Maybe looking at it in some other different way. We have to try for such things, like maybe looking at it for some other different way, maybe trying to say what you can say. There are all the ideas, right? I'm trying to see, maybe trying to see it in some other way, okay? What are small observations we can make? Can we calculate for some sequence how many, see, for some token sequence how many of a are possible? Can we do this thing? Trying to think of this is also a good thing, because why it's a good thing? You anyway have to sum this shit over all possible arrays, right? You anyway have to sum this over all possible arrays. So instead of array a, why not just look in terms of token sequences? Both are almost similar things, right? So logically you have to think, can I try to work on this? This seems equally complex, right? Because I we can also work, see this thing for some token sequence, of length x, let's say, how many sequences of a for which this is possible, we can try to think of that. Okay. Not ready and beam in the night. I don't need no light to see you shine. We can say that the other thing that we have told already, let's say. So one for this, the token sequence would be 2, 3, 4, and then you have some choice here of removing some other things. But let's say in our token sequence, so token sequences are, these are like all excellent permutations, right? These are like permutations. For all possible permutations, you will try to find what are the things you can remove. Maybe even this may not be simple. Solving on streams is not that easy. Hey, N is 5000. I haven't seen that thing though. So N is 5000. So we can solve this in n square, it seems. Okay. I have to read the problem well, at times at least. So we have to solve this thing in n square. We need not even solve this in less than that. So, oh, if you have to solve this in n square, then then we can do better things, right? Hey, if you are allowed to solve in n square, that makes the problem. Maybe we can store something else and then we can try to count somehow, right? If you are allowed to solve this in n square, if you are allowed to solve this in n square, maybe you can do some dp, right? Not dp, like maybe you can count them in. See, in to simplify something, you need something good in this, but there doesn't seem to be anything good in this, right? We have seen this well. It's becoming cases when this has been chosen for 2 greater than 0 itself. It's becoming cases. If this comes here and then this comes here, if you choose here, then it is total length. If you choose inside, then it's length minus 1 for the next thing. So till here itself, you cannot get one final simplified formula. That's being obvious here because it's getting complicated, right? But then I thought I should have seen this n square, right? You guys should have helped me too. You guys should have helped me too. See, n square lets us maintain more things. Okay. So what we want to maintain, if we can know number of things in this that have been removed, then we can solve the problem further, right? It seems like that now. So if you know number of things in this that have been removed, then we can go further. So maybe we can group all the remaining things using that value and then we can proceed further now. If we can maintain more number of things. See, whatever our problem was here, we don't know number of things that have been removed in this previously, right? So we were not able to simplify that, but now we can just fix that shit. Let's say for all the previous sequences, we will group them into number of things that have been taken from here kind of thing, okay? Somehow number of things that have been gone from th- this thing, we know that. Let's say number of things that have been gone from this thing, let's say we know that. Then we can proceed further, right? Do you guys get what I mean? So what if, fuck, I tried issues. I hope my laptop works. Oops, I can't see all of show all of the things to you. People. Fuck. Yeah, I'll just move beside. See, with O of n square it became direct. But even without O of n square, I can see that even without O of n square, I can see that what is this thing? No water, bro, no water. Yeah, I use a tissue, it seems fine. It seems fine. This is my important laptop. I cannot even say what laptop it is. Yeah. But so yeah, do you guys see what was the complexity here? When trying to remove this token, we want to know how many things in this have been removed, right? How many things in this have been removed, we want to know. When trying to remove this, that will depend on if this has been removed or this has been removed. That's why we were not able to simplify this whole shit, right? But now, but now, let's try to. So now this is becoming too obvious, right? The solution is becoming too obvious. We will group our. So we have sequences, right? We have sequences. Even this is a bigger idea. Even this thing is like a very good idea, right? Trying to see something else. This would have been like 2700, I guess, probably. So that's why this problem is being too direct now. With n square, it's being too direct. Fuck, fuck, fuck. I will also once rub the screen. Morning, I could stare watching stars. I could... Yeah, I have rubbed the screen, but now this is becoming too obvious, right? What we should do is becoming too obvious, right? So what we should do becoming too obvious. So what do we do? So we have one. So let's say we have 2, 3 up to so on I minus 1. And then when we are at I, let's say among all the possible sequences, number of things. So if we are computing this thing for some j here, we have what exactly we want, we will try to have that. So For all possible sequences, we will try to split this for all possible. For all possible token removal, comma, sequence A. I'm making it complicated, but what I mean is the summation, whatever we are trying to maintain, right? So this is it what we are trying to maintain. For all possible sequences, comma, all possible token removal different sequences. These things are we are trying to these different these things that we are trying to count. Like if some sequence gets fixed, number of token removals for that. So this, let's say we have this thing, okay. Now we want to split this thing based on number of things till here, number of things that have been removed till here, okay. For some j, for some j, let's split all these things into number of things that have been removed in this range, okay. So if we can have dp of j comma x equals to, because that's what we want to proceed further, right? For each j, if we have number of things that has been removed from this 0, number of things that has been removed from this 1, number of things that have been removed from this 2, number of things that have been removed from this 3, up to so on. For each of that, if you have, so for each of that, let's yeah, for each of that, if you have dp of j of x, which is number of sequences x things have been removed here. So let's just make it x things are present. Why am I doing this is, once we consider till here previous things, you will definitely remove something from here, right? So for these things you need not update, let's not worry about that. I'm trying to keep these things because okay, for that reason, if we have this, so if you have these things, then you can have answers when I gets added. How? When I gets added, what happens? Let's say a of I is j, for example. When I gets added, you can find dp of total sum by trying to see when I gets added. Can you recompute these things? Is what we want, right? If when I got added, can you recompute these things? Is what you want, right? For all these things, it doesn't change at all. Why? Because when I gets added, if it is 0, if it is 0, then you have to add one thing to everything, I guess, because if it is 0, then you have to add one thing to everything, because for each of them you have one more thing, right? But let's just see if it is non-zero. If it is non-zero, then you have this range, and then let's brute force again. Let's say you're removing this one. This was the final token that you're removing. This was the final token among these things. This was the final token that you're removing. For that, what do you need? Let's not even worry about what you're removing. Let's just worry about how many things are present here. But then we have to worry about what we are removing to, because if you're removing this, all of these things will have, like, for this it doesn't, we don't have any change, right? But for all of these things we have a change. Sorry, if you are removing that, for these things we have some addition. So can I just brute force on that and then find the values somehow? Maybe we can try to maintain something else too. Let me try to think for a minute. Okay, see, I may complicate things even if it's an easy problem, so don't think this problem should be solved this difficultly. So let me try some more time. See, if we have this thing, we can calculate dp of I. We can calculate answer for I for sure. I'm trying to see if we can again calculate all these states again. So how do we do dp? First we try to count what we want. Then we see what became complex. This thing became complex. Number of things in this segment became complex. So then what do we do? If that thing becomes complex, yeah, then what do we do if that thing becomes complex? Sorry, initially we try to find answer, and then whatever has become complex we try to think, okay, we will also store that. We needed value, a number of things that have been taken here or number of things that are present here when we are at ith step, so that we can choose one of remaining things, right? So I'm also explaining DP here. Okay, in DP, what do we do? We'll try to compute what we want, and then we'll see what is stopping us. So if we know this number of things that have been removed from here, if we know that, then we can proceed further. So then what do? We try to find that also. We try to split things into that. We try to group them into that thing. So here I'm trying to split things, right, based on X. For this thing I'm trying to split them into based on X, like number of things that have been taken from this suffix. So far we have this suffix, and then in that suffix number of things that have been taken. Such token sequences we are trying to count number of them are there. We are trying to split all token sequences commas all token removal sequence comma sequence A into groups based on number of things that have been removed from this suffix, because that's what is important to us. So that's how we try to group them, because once if you have grouped them, then we can proceed further, right? So if I try to see now, okay, is added. Can you calculate dp of j comma x again? To calculate dp of j comma x again, to calculate for for these things it doesn't change because x is number of things which are present, right? So for this index, for suffix, we definitely one of them will be removed. So it doesn't change at all, right? Because one got added and one will be removed, so it doesn't change at all. But for something here, we want to know number of things that will be removed from here. But then if 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 we are removing something from here, then that value changes, right? Do you guys get me? So let's say we are trying to maintain this thing. Is dp of j comma x a bit clear to anyone? Yeah, maybe, but I think this seems computable. This seems like findable. So let's see. Uh, so if you're trying this dp, right? So let's try to say we want to calculate for all the values, right? Let's say this is ai, and let's say we are j here. What do we want? Now we have one more element, and then we will remove one more sequence, right? We have one more element, we will remove one more sequence. We have current dp of j of x, right? So in all the cases where you remove one thing from this, from here, let's say removing one thing from these things, like at last step you're removing one thing from these things, let's say, then what happens? You can do that in, you can do that in all the sequences. So we have two cases, right? If you are removing the final thing from something before that, let's say if you're removing something final from here or from here, those are the two cases we have for this j. This should be easier than what I am doing, but I don't think there is anything else we can do. So see, till here it's direct, it's just needing work from us. If something among this has been removed, then How can we split? Let's say two cases. Something from this has been removed, or something from this has been removed finally. These are the two cases, right? So if something from this has been removed, and then you have X things present, what does that mean? DP of, let's say DP new this is, so whole DP of J of X. So we have X things. Let's say we have X things. And then among those X things, one thing got new. So it became X plus 1. And then you can choose. So X plus 1, X things are present here. Okay. And then this one thing has been present. And then one thing has gone. So X things have been present till here. And then we have X plus 1 new things. You can choose X plus 1 among them. That's it. Damn. Plus, if you are choosing something from here, so let's try to see this again. DP new of J of X is X thing should be present finally here. Initial DP of J comma X is all the sequences where X things are present till here. So now we have one more I, right? Damn, even AI varies, right? We should find this sum over all AIs too. Should we simplify something? But let's try. Let's still try. AI varying is not that difficult. AI varying is nothing but times AI falling before this, right? Times AI falling before that. That's it. AI varying is not that difficult. So let's fix AI and then try to see how difficult is this. So we want if one case one something is being removed from here, and then we have finally X things in this suffix. We are adding a new element I, and then we are again trying to maintain whatever the states we have. Okay, added a new element, we have X things, means finally we have X things, means one has been removed, so there should have been X plus 1 things, and this one came additionally. That means from here to here there should have been X things already, and then among them one have been chosen to have X things finally. So among all the X plus 1 things we can choose any of them, finally giving us our state DP of new. Plus we are fixing AI too. Finally let's remove AI fixation too. So now something has been removed from here is gone. Now we have to worry on something has been removed from here. Okay, and they can only be removed from here to here, right? For some particular AI, even if you're lying, Kaneki, thanks for that. See, people, even if you solve one problem, we will learn something. You will learn something because this is not new for me. I even if I don't, because I have solved much higher rated problems, right? IM is easy for me. Staying IM is not stress at all. But you people will never solve higher rating problems, right? So trying to think here will benefit you a lot. I hope it does. Try to think. You're not just coming here to take my interview of asking me what I do there, what I do this. Can you do my LinkedIn request? That's not why I am here. Okay. This is some random search that I have done. Let's leave that. Oops. I can't share all these things, bro. LinkedIn is personal, I guess, right? Delete that shit. Fuck. I should be careful. Okay. So let me try to see chat for some time. So Aryan Shah, we are trying to maintain something for the suffix, because what we want is in some suffix we want to know number of things have been removed, right? That's what we want. What we want for different token sequence, comma different sequence. We want to sum something over all sequence. I'm writing it as an order pair for clarity. An order pair. Even if the sequence change, that contributes to something. Even if the for the same sequence, even if the token sequence change, that contributes to something. So what all we want to count is number of these order pairs, and then we are trying to split these things based on token removals, like number of things that have been removed in some suffix, because that's what we want. It doesn't come from somewhere, it doesn't come from some topic, it doesn't come from technique. It comes from what you want, it comes from problem, it comes from where you got stuck, it comes from what is complex. Okay. So we have this. So let's assume AI is also fixed. AI is not fixed. AI is evolving every day. We get new AIs every time. But let's assume AI is fixed here. And then we want to write this thing in a nice way. So DP, what is DP of J comma X? After you remove something here, after you remove something here, okay, after you remove something here, you need X things here, right? After you remove something here, you need X things here, which means how can you do this? Oh, so we want to write this in terms of DPs that already exist, right? See, because I'm fixing X, I can only maintain things for suffixes. Otherwise, I can even maintain for all these things too. But then, yeah, let's see. We want X things to have been removed. So it is like X minus something all the ways. All see the answer till here. These things will also influence these things, right? Okay, these things will also influence these things. Try sometimes, guys. Even one small thing can help. Let's try sometimes. Let's try sometime. If we have, so we want, we can count this thing. Is fixing what has been chosen, is that the, is that a good way? Can we, like, when this is mixing, when this is missing, so I can have it no more. So I can have it no more. So let's just write that sometimes. We have x minus 1 things here. Right, we have x minus things here because this is one more thing, and then finally we are having, and then finally we are having, and then finally we are having x things, right? So let's assume we have z things here. So let's assume from here to here. If you have z things here, left, that gives us what? I mean, currently we are only able to fix number of things in the total, but right, we are only fixing number of things in the total, but let's say we are also able to fix number of things from here to here to be z. Let's say we were able to do that. Then we could have chosen here in x plus 1 ways. That was true. And now we have z number of ways to choose among these things. Right, we have z number of ways to choose among those things. So if you have this z somehow, j of x minus 1 somehow, which says not even z, I mean z, it also, z is also dependent on this ai, like till here. Okay, this is definitely not right representation, but then we can do z times, because there are z different things, we can choose them z times. Yeah, and that's it. But then this thing, this is not that simple, right? Try, people, sometime. It's fine, we can solve it before 12. I think we can solve it before 12 if we try well. I will stop by 12, I have some other things to do in general, but 21 to 23 at least we should be able to solve. I can have it no more. Try now. I may be complicating it, but try a little bit. But what else can we do? We cannot. If these are the states, that's what we have to do. But can we have some better states? Can we see something else? I can have it no more. See, I'm trying to see if we have something for j plus 1 and then subtracting those two things can maybe they will give us the other thing falling on this side. I'm trying to see for that thing maybe if something like that is possible because we have things being here. If something falls here, maybe can we subtract things, like maybe can we find something for this, maybe can we find something for this and then just subtract those two to get that or not. So I'm just trying to look for that for 1 minute. So let's try to see if this can be, if this shit can be represented in some better way. Okay, guys, focus on the problem, please. No advice. My stream, you guys have to try to think. That's it. See, placement fear, whatever you think of, you cannot do better, right? Whatever you do finally, whatever you say in the interview, whatever you give in the test, that's what happens. It's a bit random too. You have to see it for what it is, right? It's a bit random. You cannot have full control on it, right? So what you have to do is try to do something, not leave things totally. Try to do something and then give it for some chance to, like whatever happens, right? Try, try to not neglect things. That's good enough. Try to not neglect things. You need not perfect things, right? But don't just neglect everything. Don't do that. That's it, I think, for placements, right? And then you have to prepare, right? So the results you get are not based on how you have prepared, right? It's how you have performed. There is some chance, there is some luck too. Maybe if you have done nothing from now, maybe you may perform better by some luck. Maybe even if you try everything someday, maybe you may not. So it's not that complicated thing that you have to do it so perfectly, so well, right? So don't leave it entirely, don't neglect it entirely. That's it. So let me try to just look for that thing, that because we are able to get this thing very well, and then what does that say? let's say you have let's say you have I'm getting somewhere. I think, I hope. See, I understand you may not be able to see my videos, good man. Maybe my video seems time waste to you because placements are coming up. But be smart. I don't recommend you to watch my videos because I'm wasting time here. And I don't know why these people are staying, they are wasting their time too. So, I mean, you guys will think doing something is time waste, doing something is not time waste. Why be so paranoid? I don't know if that's the right time. Don't try to be so paranoid. Like, whatever happens, happens. Don't neglect entirely, is only advice I can give. Don't neglect entirely. You need not worry about anything because everything is some chance, right? We cannot say something, we cannot be sure of anything. So maybe if you want to pass sometime, maybe try to follow one whole stream of mine. If you want to not pass sometime, maybe do something, or maybe just sleep, or maybe just jerk off and sleep. I'm just joking. There is no very strict thing that you have to follow, right? For placements, don't neglect. That's it. Mostly cover all topics on DSA, and but even can solve problem rating based on math in core process. So can you tell me what should I follow to be on track? See, my streams. Okay, people who are following. See, yeah, bro. Who doesn't know me? Do you think 750 subscribers is a small thing? I don't think so. 734 it's now. So even if we solve this one problem, it's a win. It's a win for this contest. So see, let's try to see this thing. This seems a bit complex. Trying to write it in terms of whole DP seems a bit complex. But we have covered final thing being till here, right? Now we want to worry final thing falling after J, right? Final thing falling after J is what we want to worry, right? When this has X elements. What I am trying to do is, what I am trying to do is to see that as final thing falling after J minus 1. After means before. After means this side. Okay, after means this side. Final thing falling. But then final thing falling at J minus 1, we cannot apply this well because we cannot say J is empty so far. That's not the kind of states we are maintaining, right? We cannot for sure say J is empty or J is not empty. We cannot say that easily. And then we also have the restriction that these things being X things. Can we fix like J minus one has been taken, J minus one hasn't been taken? No, that's too I don't know why I'm complicating every problem in these streams. It's just due to D. Have I solved any other problem in this? 2000 solves, and then why am I complicating it? Wait, if it is 2000 solves, I think we need not do these complex things too. So let's try to make some other observation, okay? Maybe coming from that side maybe gives us something. Let's try for those things, okay? Um, I'm having bad luck in my streams, really. There were days I used to solve, if there is practice tracker, I used to solve per day like many 2400s itself when I was solving. But recently I don't know what's happening in my streams. I want to try some other problem, but there were days I solved 2200s in 5 minutes. Maybe I'm complicating this. Maybe I have to say a bit more clearly. My earphones too got wet. Try to think, people. Thinking is enough. We need not solve the problem, but we will solve this problem. So I have it no more. Fuck, I'm being very unlucky in my streams. What are these ratings? 21, 22, 23 only, right? But this will make it worse for you people. But then why is it becoming like this? It should be a simple n square dB, maybe not this complex n square. But then this is the simplest n square dB we can get, right? I'm still trying to see if f of a can be simplified a little bit. I don't know why. Maybe tomorrow I will have better chance. Tomorrow is due 3 explanation, right? But it's fine, I guess. I haven't solved anything in last two streams too, right? Even if we get one dp of j comma x, we can't probably find these values for all j's. We cannot update them for all j's and then all x's, right? So there is definitely some simplification. Wait. Guys, we fucked up this. No, bro, I cannot give that. Guys, to save the stream, let me try some other problem too. Okay. I don't know if I became bad or not. Why the fuck am I not able to solve any counting problems I'm very good at? I really don't understand. Have I read the problem wrong? Already if and only given a weight of valid sequence to this space insert point. Sequence during other. See, it's just assigning for each non-zero we have to assign one thing that falls within the range. So if you're coming from behind, see, I was thinking many times to look from behind it, maybe coming from last element, but then I never did that. But then I never did that. If we try to come from last element, let's say, okay, it can be taken in, but then when we are here, let's say, let's just look at last but one, okay? When for this we have another range. Now we want number of things that have been taken, the same thing. Let's say an lasted from here, and then we have j. Okay, I think I have to stop somewhere if something goes complicated, right? I just think because I can think more, because I can try to see if we can do j minus 1, I should not keep going in that direction just because I can think something. I should just conclude it immediately that okay, this seems odd. What else can I do? Can I come from behind? Maybe we should have done that. So let's at least try to solve the problem. We have 7 minutes more. Uh, so now what happens? Now what do we want? If something has been chosen here, then we have lesser things to this. If something hasn't been chosen here, then we have lesser thing to this. So let's say when we are here, if we can find the answer for all suffixes, just splitting the previous things into number of things that have been removed for all suffixes. Okay, if we have the thing, then we can get the answer to this easily by trying to find for this suffix number of things that haven't been, that are there till here to here. Let's say suppose somehow we have that for all suffixes. When we are here, when we are j, we have for all suffixes number of things that have been, that still exist in that. So let's say we somehow split all token comma sequences into that thing while coming from behind for all non-zero things. Let's say somehow we have done it in that way. So now, how can we make it now? So let's say we are at I, and then I plus 1 is this. So for all suffixes, we have dp of g of x is, let's try to quickly think. Let me think. Because if it's again difficult, if again this is also being difficult, instead of making things clear for you people, let me think once. Uh, if there can be x things here, if there can be x things here, and let's say I plus 1 is removable, okay, then we have some ai plus 1, right? We have some ai plus 1, and I have, I know number of empty things here, and then that's simple. Assign something among here. That's simple. If I plus 1 comes here, then what do we want? If I plus 1 takes this, if I plus 1 comes here, then what do we want? But if you're coming from this side, even then, these things are not that simple. But they are a bit simple. Still, they are not that simple. Because greater things can. I'll go 1 minute to washroom. It's crossed 12 already. It's not that great, I guess. Is it real Nick? I don't think so. Fake Nick. I thought because real Nick can do such things, right? He streams. That's why he doesn't stream. He uploads videos. That's why I just expected a little bit. Bam bam. 1 minute. dp of I of x be like till IVC, but then the last thing will take last thing is everything before will get 0. So we are trying to count token sequence comma a, right? But in this token sequence comma a, everything before is normal. Okay, just the last thing will have multiple things mapped to it. Just the last thing can have multiple things mapped to it, and when it is having x things mapped to it, we call it dp of I of x. And how does those x things mapped to it will appear? They will take distinct t1 t2 up to so on tx. Okay, and after taking those distinct t1 t2 up to so on tx, each different value of a1 a2 up to so on ax will be a different sequence. We have to count these things. We have to count till I minus 1 normal sequences, and then this thing having these many things where all these things are unique. But then we can move this to somehow I minus, right? So let's, this is what we are trying to count, some token sequence comma a, but the restriction is when a is 0 token sequence doesn't exist. When a is non-zero, I can't even think how this can work. This is just being dependent on uh this is just being dependent on this, right? AI less than or equals to I, it's just being dependent on that. Can that work? And then I have to count these things clearly. Okay, so now let me try to write what is dp of I comma x in terms of dp of I minus 1 comma x's. Okay, dp of I of x equals to, if, so we have x things here. dp of I of 0 equals to, which means we're only considering prefixes, and then we're only considering prefixes, and then I'll say if any girl texted me. Just joking. No, not the ones I would consider. Not consider like I would. Damn, some people are watching. I cannot say such things. I guess. Damn it. Not the stream though. Yeah. I think this seems working. dp of I of 0 is this not getting anything. Means ax is 0, the token sequence also will have it 0. If ax is 0 of n and token sequence is 0, see these things are ordered pairs. Like token sequence will have first a1 comma t1 comma a1 t2 comma a2 up to so on. Last things can have multiple things. Okay, that's the token sequence. And then if ai is 0, t1 is also 0. Okay, that's the token sequence comma a. Token sequence a is what we are trying to count here. Okay, so dp of I of 0, so is nothing but the last thing is not having anything, so last thing is being 0. So the token sequence of that would be just dp of I minus 1 of 0 plus dp of I minus 1 of 1, right? The previous thing having exactly one thing, or the previous thing having exactly one thing, or the previous thing having two things. That's it. Everything normal, the previous thing having one thing, or the previous thing having two things. Right? Sorry, previous thing is also being zero, or the previous thing having one thing. Because our assumption is if previous thing is one thing, previous everything is normal. Like there can be zero or one only. But if the previous thing is having zero things, that's also the same thing. We are fixing these things. Number of things we are fixing exactly x things. Okay. So let's try to look at dp of I of x. See, we know very well what we are counting. We are trying to count number of these token sequences possible. Token comma a1 sequence is possible. Okay, it's not just token sequence comma a sequence, which we can see it as token comma a sequences. Okay, so we have some t1 comma a1 up to so on t2 comma a2. This thing we are trying to see when the last thing is zero, which is it will be 0 comma 0. So that is 0 comma 0. All that matters is how well these things can differ, right? So now if you look at dp of C, we have to be very clear at what we are trying to count. I'm trying to count number of different sequences of t1 comma a1 where all t1, t2 up to so on tx are distinct. All of them are distinct. Okay, where all of them are distinct. That's the only restriction. All of them are distinct, and then we want tx greater than or equals to ax. This is another restriction. Okay, all of them are distinct, and then we want tx greater than or equals to dx. For now, let's look at dp of I of x. We have we have x specific lost x specific pairs in our sequence that we are trying to count. Those are fixed, not fixed. These things we are trying to count. Okay. So if we are trying to count these things, now let's assume one thing. None of these things, none of these things, let's split them. Some ti. I hope at least one viewer is there. If people have stayed yesterday till 2 on some 2900 problem, they will stay for this problem where something is hopeful, I assume. I hope. Uh, they can just look at me, right? I'm just joking. If some ti means just among the last x things, okay, is I or no. These are the two cases, right? If no ti is I, then what does that mean? We're trying to count these sequences. Now we don't consider uh, there are each different As, and then we have each different tx's. We don't consider that. We are looking at this. This is what it is, because we can take some particular ax value, and then corresponding ti's value. That's a valid sequence, and then that's a valid f of n too. So see how I'm trying to count things. I'm trying to from the very beginning I have this idea of trying to count ordered pair of token comma a, and then I made it ordered pair of t1 a1 t2 a2 because order pairs doesn't change, right? In that way, see the clarity I have. It's not like doing random things, but I don't know if it works or not, so let's try to see this. So if none of them are taking that, then what does that mean? All of them will take some ti less than or equals to I minus 1, right? And ais also will be less than or equals to tx after that. So that's perfectly dp of I Let's clean this here. Let's clean this here. The previous thing being, if I minus 1 is 0, that is dp of I minus 1 of x things. Because if I minus 1 is 0, that is being 0 comma 0. Right? That is 0 comma 0. And now we want these many order pairs coming onto this. That's perfectly this. If I minus 1 being 1, these are the only two possibilities we have. Okay. Initialization also we have to be careful. dp of I minus 1 of x plus 1. Right. Because now we have one more thing, which is like t0 comma a0. That also should be assigned something. And then we have all these order pairs trying to again get these values. So this plus this is perfectly splits these things. These things will perfectly split these things, right? Because x plus 1 pairs, there is a bijection. Dynamic programming is all about bijections. There is a clear bijection between one thing here, x plus 1 things, x things here, two, x plus 1 things here. Because you can just move them here and then they all satisfy these constraints of nothing is being I. So now if something is being I, so now if something is being I, we have x fucking things, right? And only one of them can take this I value because TIs are distinct, right? How many ways that's possible? XCI times among these XCI, among these XCI times it's possible, and then for all of those things, A2 should be. So we are trying to select one pair now. Among these things, we are trying to select one thing and then we are fixing that to this. So that can be chosen in XCI ways. After you choose that, so now let's say you chose TI. So now TI equals to X. What X can be? AI can be. AI can be, it's not 0. AI can be 1 to I, right? Because only constraint we have is TX greater than or equals to AX. If it's not 0, if it is 0, both are 0. AI equals to, I mean, I haven't solved such nice problems so far. This is really exciting to me because I haven't used this nice idea somehow. Like this idea in the sense, like trying to see things clearly. Like idea here is like trying to keep them in this way instead of going over each subsequence, each each sequence is just mapping. When AX is 0, make it 0. When AX is nothing, you have to map something to that that comes, yeah. We're just doing that mapping where TX are distinct. So only one can be assigned, and then the AI can take I different values. AI can take 1 to I. So I different values. So now that thing has been fixed now. If that thing has been fixed, what does that mean? Everything else or just dp of I minus 1 comma everything else must go before now. X minus 1. I hope at least there is one viewer. This may be wrong, but I hope there is at least one viewer. Good night, Abhishek Sharma. Zaid just came now. He wakes up late or what? So we have people. Is this understandable? Like what I'm trying to, what I mean is is the way of T1 comma A1 understandable? I'm trying to see for each sequence we have one this thing. We have to count T comma S, number of different T comma S. We should count number of different T comma S, right? Summing f of a over all s, I am seeing that as t comma a summation. From the very beginning, I'm doing that. But then the same idea somehow simplifies things. So we have this clear, very clear fucking formula for dp of I of x, for dp of I of 0, just in terms of I minus 1. For dp of I of 0, we have this formula. So we have everything we want, everything we need. For x is 0, this is nothing but this. And and so now we only want dp of 0. dp of 0 of x is all what we want. Right? dp of 0 of 2 is 0. Greater than 1 is 0 because you cannot assign that many things when you have only one thing. dp of 0 of 0, you're not even assigning this thing, is 1. dp of I felt good inside for months the only life with you can. I think be alright. I feel good inside. Let's also write dp of I plus 1, okay? We go till here because we know dp of I plus 1. When we try for dp of I minus 1, we may use I minus 1 comma I. dp of I of I, we may use, or dp of I comma I should be 1. 1 minute. I think this is fine. You cannot assign I plus 1 things. Let's see for I if it works out. For I, you have I minus 1 comma I plus 1. So I think we need for I 2. dp of I of I. dp of I plus 1. Because x is increasing, right? Not everything is decreasing. I decreasing, but x is increasing. Right? So I'm just trying to make sure that we calculate things correctly. This is 0 for sure. And dp of I is 1 probably because you have I things. Let me take let me take one based indexing. Do not confuse things. One based indexing. Just for this. You have one thing and you must assign that to something. Only 1 comma 1 is possible. You have one thing and you that is 0. AI is 0. Then 0 comma 0 is the only sequence you can get. And for everything else, it's greater than 0. It's you cannot assign too many things while keeping t distinct in this way, right? So did you guys notice that I just observed one thing in the beginning here? I didn't even care about what we have to count until here. So that's the structure of the problem. And then I was worrying about how to count what we want. dp of I is we have I things need these things means this is not one, that's not one, but this should be handled by this itself. right? This should be handled by this itself. dp of I plus 1 is 0. Now, if you see dp of I, it's accessing dp of I minus 1 of I plus 1. That's the only concern, right? But then this is 0. So that access is fine for us. That access is fine. That is 0. That access is fine. I thought I was confused. This access is fine for us. That access is fine. I comma I will at max go to I plus 2. I was thinking about memory, but then at max it will go to I plus 2, right? So let's just maintain till dp of I of n plus 2 to not care about such things. Okay, such silly things. I'm maintaining till n plus 3 because I don't want to worry about I minus 1 and then I plus 2. I just don't want to worry about that. Okay. Let's make everything 0 in the beginning. See, people, see, people, NCR. If you are my viewers, how you should view NCR is number of ways of selecting R elements from N elements. You know sets, right? Let's say you have a set 1, 2 up to so on N. Now you want R length subsets. Number of R length subsets is NCR. I'm telling it again and again. NCR equals to NC N minus 1 CR plus N minus 1 CR minus 1. You people should remember this well. Okay, I will tell you people again how that comes. We have, sorry, we have n things. Okay, n things. We have to choose our things. Okay, and number of such subsets is what we have. Number of such subsets. Now, split these subsets into two things. Things that has one already, things that don't have one. Okay, subsets that have one, subsets that don't have one. So now we have R length subsets being chosen from 2, 3 up to so on n things, which is n minus 1 CR. And here, 1 is already there. You have to choose other R minus 1 things from n minus 1 things. That is n minus 1 CR minus 1. So NCR equals to n minus 1 CR plus n minus 1 CR minus 1. This should be the way you Remember this formula, okay? This should be the way. This formula is bad, but ncr plus ncr minus 1 equals to n plus 1 cr is famous. It's just like keeping n as n plus 1. ncr plus ncr minus 1 equals to n plus 1 cr. So remember this in this way, okay? Be my viewer, remember this in this way. Like binomial, okay, but how you knew, did you knew this like bijection proof? This is bijection. All dps are bijection. In dp we will try to make bijection. When I try to move those things here, I was trying to make a bijection between x things set here and x minus 1 things set here. So now what do? We want ncr. N is just 5000, right? Let me maintain an ncr array, okay? Wait, the what the fuck? It's not even xci, it's just x into. We have x things, we have to choose one. We don't need ncr, people, sorry for that. But we should have been very careful when we have written this shit, because we cannot correct mistakes once we make them. Best implementation debugging tips are trying to be careful at every step. That's the only step, that's the only debugging tips we can get. There are no other debugging tips, they don't work for me. We should be very careful at every step. That's the only thing we can do. Debugging means. What is dp of I of 0? It's dp of I of x equals to. We have noticed that this is common for dp of 0 also, right? I minus 1 x minus 1, it seems. Let's also verify why it is I minus 1 x minus 1, because one thing has came here. Now, do we have cases here? No, there are no cases. Why it is I minus 1 x minus 1? X things are here. And then, wait, we should have cases here. We should have cases here, which is I minus 1 currently being 0. And I minus 1 currently being 1. Right, because if it is already having something, we have chosen one thing here. Now it's like the thing has been fixed. So for remaining things as a sequence, we want, if this is 0, then it's I minus 1 of x minus 1. If that is not 0, if that is having already and it's something, we have to be very careful, people. Otherwise, we cannot debug this shit, right? We are using math here. What the fuck can I debug? I can only be careful. It's dp of I minus 1 x minus 1, I minus 1 x. plus dpf I minus 1 of x. Because our assumption is only the last thing can have multiple things. Everything else will have one thing at max. And it can be 0 or 1. Everything before can be 0 or 1. If it is 0, it is useless. It's just 0 comma 0. I have no hope that this sheet will work. Okay. I have dp of I plus 1 is already 0 because I have initialized things to 0 here. I have no hope that this sheet will work. But the answer is I know this won't work. I don't want to run test cases. See, you guys have to admit that I am good enough to do streams. Isn't this good? What the fuck did I write? I just changed this at the last moment. Sorry, this thing. I just changed this at last moment. I have made a comma something into something like this. And then, how the fuck did this work? Is this clarity? Simple code. So when I say solutions are simple, proofs are simple, implementations are simple, I mean it. Because what's the idea here for solution? Trying to see that I can't even know. Okay, trying to see that there are some constraints. What are the constraints? Everything will get assigned to something. That's the only constraint. That's the only assignment. And then if we come from behind, it's simple. If last thing is being that, then that has been eliminated. If that thing is not being that, then it's like that's not this. Now all it says is this thing is having two things. So when we are able to make that one step progress, just one step progress, like being able to remove last thing, we're able to solve the problem. Did you see? And here, what I counted never mattered. What I counted never mattered because I came to here finally. But before coming to here itself, I realized that we can do this thing. I realized that we can do this thing. Looking at these two things, and then I realized that I can do this thing. A and 0, then a and not equals to 0, then we can do something like this. And then I thought of, okay, now what to count? Because the structure seems repetitive because everything is repeating. Because if that's not this, then ai is less than or equals to I because ai must be less than or equals to that. Otherwise, it wouldn't work. If you are only seeing valid a comma t's, and then it's nothing but this thing, right? So we are able to do that progress. So the constraints the question has, the constraints, the kind of constraints the question has, making it possible for us, right? If if the ranges are not I less than or equals to I, if the ranges are ai less than or equals to bi, this can be solved because you cannot apply that thing now. Even if you come here, this thing can have till here, right? If ai less than or equals to bi, now you cannot solve this. The problem is only being solved by the fact that we have ai less than or equals to I, and also ai ti will be less than ai less than or equals to ti. Because of these two things, we are able to proceed further. See, what great idea is needed? Somehow trying to use ai less than or equals to I coming from behind. But with no error, simple code. So that's why solution is simple. Did we miss the proof? We have not missed any fucking proof, right? Otherwise, uh, this is a clear proof. I have been clear. I have tried being clear at night 12 o'clock. And then implementations will be simple, right? You may think the implementation 5 degrees as problem has been solved. We can go over in the increasing order of 5. And then I'm just trying to make sure that we have all the corner cases covered too. Because if dp of I of greater than I is not 0, then it keeps going, right? It keeps growing. This side will keep growing, but that will be 0. So we are done. So this is a good stream, right? See, maybe other solution is different. The idea we used, the learning we did is good, I think. I don't think everyone will might have done with this clarity, right? The clarity we are using is good. The clarity. You guys can learn now how you can see things. I'm just trying to see all A all A's as summation over of f of A of all A's. So I replaced long back itself I have done that. What? When I wrote this thing, even before that maybe. So so f of A was not getting simplified. For sure f of A is not getting simplified. So because if we see two things itself is not getting simplified. So we have to see, so we cannot find f of a, but we can find this summation. See the problem. So it's a nice problem. I didn't expect this much of a problem. I didn't expect this much of this problem, but then it's a nice problem somehow. Maybe people found this sequence online because 1, 2, 3, 4, 5, right? It's just dependent on n. Maybe people found the sequence of this without doing this DP. Maybe they know that this is some famous sequence, and then they have accepted it or not. Maybe I don't know. I'm not sure, but we have done it in a nicer way. What we have done, we are trying to look what we have to, the whole summation itself we are trying to see. Ordered pairs are good for clarity. Ordered pairs are always good. It's this is like double counting principle. In combinatorics we have first bijection principle and then double counting. These two are the basic ones. I have explained these things little bit. Double counting is you can count these ordered pairs by fixing sequence A, and then it will be sum of f of A. Or you can count these things by fixing token removal. This was the idea I was trying somewhere else. That was the idea I was trying somewhere here. And then what we have done, we have observed that we can split these things and then come from behind by considering some other DP. But then this worked. It feels good, right? If you guys have followed. Oh, okay. Let me say you this thing. Let me say you this thing. Do you guys think? Please answer this question. Same question. Same question I'm again asking. Based on this thing, did we get a great idea, or did we finally realize that we have seen ai less than or equals to I for what it is? We have seen sum of f of a sum of f of a over all sequence for what it is. It is not sum of f of a, it is sum of all possible t comma a, where t comma a is a valid sequence. is no is a valid operation, and t comma a is nothing but an assignment. Whenever a is 0, it's not getting assigned anything. Whenever a is not 0, it's getting assigned something which is greater than or equals to ai, and all the assigned tokens should be unique. That's the only constraint that we have. So we have seen some of f of a for what it is. Do people realize? Hey, people in the chat, it's not like I'm getting some random great ideas here and then calling it problem solving. But then what we have finally done, we have seen this for what it is, we have seen this for what it is, what summation of f of a, we have seen that for what it is. Do you guys see? Do you guys get that we have seen the problem for what it is? Maybe it got solved because it is a famous sequence. See guys, so in contest, don't try to do like me. Like me means trying to use some memory from my streams. Don't do that. You can follow my ways like Pradeep Kul has told. You can follow trying to write things down clearly, because many times the mistake I made was trying to go deep into something before making some small observation. That's a very common mistake I make. So trying to write things clearly down is a good thing, because you have to judge the problem. It's all about seeing the problem for what it is, because I have finally proved my point that it's about seeing the problem for what it is, right? Memory in the sense, don't try to think of trying to use some memory to do that, because you have to see the problem for what it is. You should not get some technique. Yeah, I'll sleep well tonight, I will sleep with peace. It's like I have banged someone in the night. I haven't done any such things, but yeah, that's the satisfaction. uh yeah, good night people. Okay, I will just end it a little bit. What I mean is, Pradeep Kul, don't try to use memory, because if it is about seeing the problem for what it is, try to make whatever observation you can make. Try to think, okay, if there exists a simple, oh, there is a lag. I see there's a lag. I sense there is a lag. Okay. What analyze? What I mean is, writing observations is good. Okay, seeing examples is good, because I sometimes entirely miss out. In practice also it's good because it's good. It's my bad habit. Don't waste too much time, because here you cannot do much with examples. Maybe, see, if something is ambiguous in the question, you have to see the test cases. That I missed many times. I missed two times. I remember two contests getting fucked up because something is ambiguous and then I haven't seen it for what it, I mean, and then I haven't confirmed it with test cases. But everyone else who might have seen the test case might have eliminated my doubt initially itself, right? If I'm being logical. So keep me your handle, bro, Riyadh. I'll try to do that quick and then I'll sleep. So we have done good today. Someone told me, Yashmata has told me to sleep well too. So guys, do you also notice once I got the idea, how quickly I have solved the problem? How quickly have I solved the problem? Once I got this small observation and idea. And that fits perfectly to everything. And then I was confident too that this is right. Great coders, like high rated people, when they are here itself, they can analyze that, okay, this shit is not working. They would have analyzed that. And even before thinking of this, they will think, what is very peculiar about this function, about this thing? This is a bit peculiar, and these things are also a bit peculiar. Maybe coming from behind is the first thing to look at, rather than going deep into this, right? Rather than calculating f of a for all possible somehow, I mean, before this, small observations are important. Coming from behind may land us in this idea, right? So, what they do is they don't go deep into something before judging their path. They judge the path. Okay, this seems bad. And I will tell what's the difference between masters and the previous people too. If some question looks complex, the previous people will give up. But masters may know these questions are shitty. Maybe some always when they ask you to find maximum value, maybe n is always possible. When they ask you to find minimum value, you will think we have to think a lot. But then maybe zero is always possible. So masters will try for such things. That's the shittiness of code forces. So believe in these golden rules that things are simple and keep trying. That's the only thing, because you have to see if you can solve the problem, how you can solve the problem. So our Riyadh is not giving his profile, so I cannot review that. I don't think there is much as profile review. You have to analyze yourself, and then what I can say, it's been stable so far. You are doing well. You're doing well. Try a bit harder ratings too. They are not difficult. Let's see what this rating is. It's just 21. Guys, I bet the ideas I have used, the way I have solved, is not 21. Believe me, I have experience. I have solved much difficult problems. I know the ideas that I have used was at least 29 or 20, 28, at least 28 level. Really, believe me, because I know this is 21 rated problem, but then I have solved so many problems, right? The idea is good. Maybe there is some other solution. Maybe it is some famous number. Maybe there is some other way, but maybe there is some other way. But I feel good about the idea because most of the time things will not get simplified like this. You should not paste link. You should paste your handle. Link will be removed, Riyadh. Guys, I am really telling you, I can judge the problem because you guys have to believe me. I keep time and then I can solve difficult problems because I have solved few 3500s too, right? If you see, three, 13200. Can we open the problem? I can just go to those things here. I mean, I have solved some difficult problems and I know that I can judge the problems. I mean, this is recent, March 20. And then simple. But then this, I was thinking really deep long ago when I have tried this one. I was thinking really deep. I don't know if I can do that now. D1 got solved instantly, but then D2 got accepted. Complex, not too complex, but then this, I was really thinking nice here, a bit deep here. So, guys, I'm ending the stream. I cannot do more pre-fall reviews except for Riyadh. I can write for Riyadh, but then it's not happening. Nah, nigga, not in contest. Then I wouldn't be here talking to you people. Just a joke, guys. Don't take it serious. Guys, good night. Bye. Thanks. I'm ending it. Riyadh, maybe you can find the group and maybe you can text me your handle then, because you have tried many times, right, to paste the handle. So maybe you can text me on WhatsApp. Maybe don't. Do you know the group? Good night. And you guys get to see my muscles a bit before going. Yeah, I also have abs. Bye. Find the post link somewhere else. Good night, try.